Hello and welcome to the final part of our GitHub Copilot alternative series. I will call this part 3. If you don't know what I'm talking about, click here to view the entire playlist, where we discussed how you can use these alternatives on macOS and Windows. Now we will run the same alternatives on Linux, which are, first of all, TabbyML and LlamaCoder with ollama. So let's start with opening the TabbyML website. I have my browser here and I will open TabbyML. Come on, you need to go to the documentation, so I will click on the installation. Let me close this, make it bigger. And for Ubuntu, the best way to do this, or for any Linux version, is to do it via Docker. So if we run this command, it will run directly with GPU. And if we run this command, it will be with CPU, just like we did in Windows. So I'll skip this because it's pretty straightforward. We can just directly run this after installing Docker and it should work. However, for running it via GPU, we require the NVIDIA Container Toolkit, and it's not as straightforward as it was in case of Windows. So let me quickly show you how you can do it. The first thing that we will do is open our terminal. If you are on Ubuntu or actually any Debian based Linux system, you can do Alt-Control-T and it will open your terminal. Let me make it bigger. First thing that we will do is do an update to make sure all our packages are updated, and then we could install anything we want. Let me install curl because we won't have curl here. Great. And now I see a lot of NVIDIA installed, and for sure we need to remove those before we could install our NVIDIA Container Toolkit. If you're wondering what NVIDIA Container Toolkit is, let me go back to the TabbyML page. Yeah, if you'll see, it mentions here NVIDIA Container Toolkit, and if you'll Google it, you can find ample details on it. So if you see, it exactly enables you to build and run GPU accelerated containers. In Windows, right after installing Docker and installing CUDA, we had it out of the box because the drivers were already there. And for running it on Linux, we need to do some stuff. It's not very tough. You just need to know the right commands. Now here it mentions that I could simply copy paste this stuff and install NVIDIA Container Toolkit. But before we do this, we need Docker. So let's go back to our terminal and let me show you what OS I have. PC OS release. And you can see I'm on Ubuntu 22.04. If you want to check the version, you can see that I'm on an AMD 64 machine. Let me clear it. And now if I'll show you my Ubuntu driver devices, you can see I have a GeForce GTX Ti mobile. So I have an NVIDIA graphic card. Alright, the first thing we need to do is we will remove everything that NVIDIA has installed. So you can simply do it by this command. And it will remove all of these. So I'm doing this so that I remove all the non-essential or incompatible version of NVIDIA drivers. I'll just remove them. And then once that is done, I will reinstall them so that we have the exact version that we want, which works correctly with the NVIDIA Container Toolkit, which we will also use to run our Docker with the help of GPU. Alright, it's uninstalled, and now I should do an update just to make sure everything is clean, and then I will do sudo apt upgrade because why not? And now I will install the drivers using this command. So it's called Ubuntu drivers auto install. And by the way, this is just the process that I followed. You don't have to follow this. If you find a better way of installing NVIDIA Container Toolkit and running it directly with the Docker installation that you have installed, you should use that. For me, I was not able to get it working until I actually purged and reinstalled my NVIDIA drivers. So that's why I'm doing this. Great. So now since it's installed again, let me reboot the system. And once it's rebooted, we'll continue with our installation. Our system is now rebooted. So let's move on to the next step, which would be installing Docker. Let me quickly open my web browser and I can simply type Docker installation. And here I could see that I could install it for Ubuntu. So let's do this. And actually there's a better way of doing it, which is by going to get.docker.com. And yeah, you can just run this script and it should work. So we can do that, and let me quickly run this. Open my terminal. And I can do, let me copy this, paste here, and let me run it on sh, because you see it's running on the simple shell. So what this command will do is call it and then pipe it to sh. So basically, instead of downloading and running, you'll run it directly. Okay. Give it my password. Now, be very careful when you do such type of stuff because we know that this is from the official Docker, because the root domain is docker.com. We know it's safe. But if you run malicious shell scripts like this, directly giving it access to the shell, it could be very dangerous. And now it should have downloaded it. To make sure that we have it up and running, I'm going to make sure that it's started. So I will do it via sudo systemctl -- now, which what it will do is it will start it now and then enable. All right, so now if I put Docker, I think it's Docker version. Yeah, and you can see Docker is installed. The version is 25.0.1. Let me clear this, make it bigger. So now that we have Docker installed, let's go back to the website. So we had two of them open, TabbyML, which I will open now here. And the other one was NVIDIA Container Toolkit. And now, because we have Docker installed, we will install NVIDIA Container Toolkit. So let's start installing it. Let me quickly copy this. And I'm going to simply paste it here. Enter. All right, let me put it side by side so that we could see it nice and clean. Great. The next thing that we need to do is now update it, because we have configured the production repository. And now we can install the NVIDIA Container Toolkit. So let me paste this. This is done. Let me clear this real quick. And now let's go through the documentation. And now we need to make sure that we configure the Docker to use NVIDIA CTK, the NVIDIA Container Toolkit. And we can do this with this command. And let me paste it. Great. So it seems it should work. Let me quickly restart Docker now. So I can do this via sudo systemctl restart Docker. All right. Now let's try to run the command. It's Docker run, but obviously we need sudo privileges here. So I'll do that, sudo, and hopefully this will work. And And as you can see, it's actually downloading the TabbyML StarCoder 1 million model from Hugging Face.
A few moments later.
Great. And now you can see that we have Tabby up and running. So it's listening on port 8080. Let me quickly open VS Code. And I can do that by opening it. Here it is. Next thing what we will do is we will install Tabby. So let's search for TabbyML. Install. And let's create a new file. Let me name it temp.py. I'll just leave it on the desktop. And I'll quickly install the extensions because of course I didn't. Let me quickly close it and let's try to see how well it's working. I see here Tabby is already enabled. Let's try to run some commands. So let's see. Let me make it bigger so that you guys can see this again. Great. I could just stop it and let's say add 4 numbers. I'll just put it add 5 numbers, sorry. And yeah, it prints. Great, let's try to quickly run it to see if it actually works. And it ran, and this is obviously not what we wanted. So let me make it a bit better. Add 3 integers. Okay. Again, not the brightest, the answer, but at least it's fast. So let's see def. Okay, now it's giving us some good answers. Yeah, it's giving a prediction of subtracting 3 numbers. Obviously, we do not want that, but I must say, using it with NVIDIA CUDA, just like how we used it on Windows, it's quite fast. I'm just typing and it's predicting the answers. Let me quickly test one more thing before we move on to the next one. So let me add implement binary sort algorithm. Why not? And def binary sort. Okay, it gave us something. Yeah, obviously it's not the right one, but you see the performance is at least similar. All right, next thing what we should do is let me go back and actually remove this, and let's go back to the website. And we saw how good the performance of GPU was. I know the performance of the CPU would not be that good. I have a Core i7 in this machine, but it's a laptop, so not as powerful as a desktop, obviously. So I will just skip it. But in case you want to try it, it's actually simple. You don't even need to install NVIDIA Container Toolkit. You can just simply run it directly. But please know that the performance would be very, very bad. Okay, so moving on, let's go to ollama and LlamaCoder. Let me quickly open LlamaCoder here. And again, we can use it via Docker like we did last time, but this time we can, I think we can use it with GPU, but let me open it first. So I'm opening ollama. And yeah, you guys already know how to run it via Docker, like I mentioned in my previous video, but here we will use the native one. So let me quickly download it. And again, it's quite simple how you want to install it. So I'm going to copy this, go back to the terminal here, and I'm going to stop it. And I'm not able to stop it. That's weird. It should be stopping. Not sure what's happening here. Let me quickly open a new tab. Just close this one. Of course, I want to close the terminal. So let's check our Docker containers. I will run it via docker ps-a to see all the processes, and of course I need to run it as a sudo user. So when I do this double exclamation marks, it actually uses the previous command, and it's very interesting. So for example, if I would say ls or I would, let's say, echo damn, it will paste it. If I just write damn, this is not a command, but if I now write echo double exclamation marks, it will actually run the previous command, which would be damn. So see, that worked. It ran echo damn and gave out the output damn. So just a quick little trick that you can use if you mistype something. So in my case, again I have to write it. So docker ps-a, and yes, you can see these are the Docker images created when we ran the command. So now let me try and stop it, and I could do it via docker stop, and name of the image or just the container ID. I could do it via this also, I think. Let me run that again with sudo, and it's done. Let's do a sudo docker ps-a, and now you can see it exited. Let me clear this and paste our commands, and this should install ollama. While it's installing ollama, let me go to the Visual Studio Code, and this time what I'm going to do is go to extensions, check the tabby extension. So tabby, yeah, and I will disable it, or I can just uninstall it. Let me reload it. Great, so now tabby should be uninstalled. Yes, it is. And we will now install LlamaCoder. And yeah, this is the right one. Let me install this. Let me stop this, and now it's installed. Obviously, it will work only when llama is installed. So I'm just waiting for ollama to be installed, and once it's finished, we'll run our code again. Great, so now I see that ollama is up and running. So apparently when we install ollama, it actually creates and starts the service, sorry, and we could check the service via systemctl again. So let's check the status and ollama, and you can see it's up and running. To stop it, we could simply change it to stop. And yeah, as you can see now, it should be stopped. So let's check the status again, and now we see it exited, and now we can run it again, ollama. I mean, you don't need to do it, I just wanted to show how you can do that. So now we'll do ollama ser, and it is serving with CUDA compute capabilities. Let's go to Visual Studio Code. This is also here. Let's go to temp.py. I see ollama here. Let's check the extension settings. Okay, so it's using code llama, which is default. We need to choose which model we should use, and it's using stable code 3 billion, which is the default one. Let's leave it at that and not change it. But if you remember, we have a very nice chart that LlamaCoder provides us, and yeah, apparently it doesn't require much RAM and should work. Let's see how good it is. So that's great. Let me close this, and let's try to write something. And obviously, like it did in our Windows video, it's trying to download it. I'm gonna say yes, and now it will be downloaded. So let's just wait till it's downloaded. Let's go back to our terminal to see if there's something happening there. And yeah, you could see that it's actually downloading. So let's wait till it finishes and then we could start writing our code.
A few moments later.
All right, it has finished downloading. So let me give it a prompt, and it's considerably faster. All right, I'm going to press tab and def add 3 integers, and it's still giving me 2, which is very weird, but let's see. Let me put, all right, and this is funny because it actually tried doing something. Of course, it screwed up the indentation, but we got ollama working. Now, obviously, depending on which system you're using, you should definitely go to extensions and choose a different model, and hopefully it will work better for you, but the setup should be the same. And if you go back to the ollama console, you can actually see what exactly ollama is doing. Now, even though the performance of the models was really good and the inference was quite fast, the quality of inference and the code generated was average at best. Therefore, I would recommend that you choose the language model that best suits your specific needs. With the rapid advancements in open source LLMs, we can expect to see even more precise and tailored code generation in the near future. And maybe by the time you are watching this video, either Tabby or LlamaCoder start supporting a large language model that is way better than the ones they have right now. And with that, we conclude part 3, the final installment of my series exploring free and open source GitHub Copilot alternatives. I hope you enjoyed this journey and gained valuable insights. Thanks for watching, and I'll see you in the next one.